Here we are. Please make sure your name and number are on the front and the back in the green section. We're going to work as quickly as we can following the steps that we wrote in our journal. So please have your journal out to the side, and you still need all these colors. We didn't really use a lot of yellow or orange, but we did use a lot of red, green, and blue, so keep those handy. You ready? It says multiply. Simplify first if you can. Okay. They're going to throw in some past skills for us. I want to skip numbers 1 and 2. Anyone from that have a whole number, I want to skip for right now. So we're moving straight to number 5. Don't put an X on it. We're going to go back. But take a look at number 5. 7/20 times 5/14. So they want us to do the steps that we learned in our journal, which if you look at your journal, it says step number 1, connect and place an X. Step number 2, stop and look for relationships between the top and bottom numbers. So I cover these up and I go, okay, does 7 and 20, can they be divided by anything? Nope. Check 7 with that one. 7 and 14? Aha, they can. So just do green tick marks and then use your pencil to mark it. So what can 7 and 14 both be divided by? They can both be divided by 7. And guess what? Instead of writing divided by 7, you can just write what the new number would be. I am 100% okay with that. So let me show you what I mean by that. Instead of having to write out what common factor you're dividing it by, you can just do this. You can just go up. 7 and 14 have a relationship. They can both be divided by 7. So I say this in my head. 7 divided by 7 is 1. 14 divided by 7 is 2. And those are my new numbers. So you're welcome to just do that from now on, okay? Next, so I've only checked the 7. Now I need to check the 5. Do 5 and 2 have anything in common? Nope. What about 5 and 20? The answer is yes. So I need the green tick marks again. 5 and 20 need to be fixed. We're simplifying first. 5 divided by 5, 1. 20 divided by 5, 4. There's my new numbers. So what I have here now is 1 times 1 over 4 times 2. We'll just use the 1 times 1 on the top, or my numerator is 1, and my denominator is 8. Therefore, my final answer, 1/8. It's pretty awesome. Simplifying first is really awesome. So now we're going to kind of put the colors to the side and just use a pencil, and we're going to go a little faster. Number 6, extend, place an X, look for relationships. 2 and 16. Yeah, 2 and 16 can both be divided by something. So I stop right there. What can 2 and 16 be divided by? 2. So I just go tick, tick. What's 2 divided by 2? 1. That's the new number. What's 16 divided by 2? 8. That's the new number. So I checked the 2, now I need to check the 4. 4 and 21? Nope. What about this one? 4 and, what's the new number? 8. 4 and 8. Yes. Those two, even the one you circled, those two can both be divided by 2 or 4. Which one do I want to go with? The greatest one. So I would divide by 4 to get 1. When I divide by 8 by 4, I got 2. So I have a lot of numbers here. I didn't touch the 21. So I have 1 times 1 over 2 times 21. Pretty crazy. My numerator is just 1. My denominator, 2 times 21. Well, 2 times 20 is 40. So 2 times 1 is 2, so it would be 42. If you didn't know how to do that, you could set it up to the side. Or you could just double both the numbers. 42. So the answer is 1/42. Pretty crazy, right? Now, look at this. If you wouldn't have simplified first, you would have 8 on the top, because 2 times 4 is 8. But then you would have had to do 16 times 21. Then once you find that answer, you would have had to simplify, which means use division, between 8 and a really big number. So simplifying first comes in handy. Okay, let's skip number 7 and 8, and let's do number 9. Here we go. Number 9, 5/24, 6/25. Extend, place an X, look for relationships. 5 and 24, nope. Check the next one. 5 and, what's that other one? Sorry, I'll get that out of the way. 5 and 25, yes. 5 and 25, can both be divided by 5. So you'd get a 1 up here. And what's 25 divided by 5? A 5 here. Circle your new numbers. And that was done checking 5. So now I check 6. Do 6 and what's the new number? 5. Do 6 and 5 have anything in common? No. So I check the next one. 6 and 24. Yes. They can both be divided by 6. Making that one 1 and that one 4. So I have a 1 times 1 over 4 times 5, or 1/4 times 1/5 is 1/20. Okay? On this next one, I'm not going to make you write this step, the 1 times 1 plus 4 over the 4 times 5. You're just going to do that in your head. So let's try it on number 10. So checking relationships as you extend the bar. 5 and 8? Nope. 5 and 45? Yes. Divide each of those by 5. 1 over 9. 32 and 9? Nope. What about 32 and 8? Yes. You divide both of those by 8. So you'll get 4 there and 1 there. So skip the step of rewriting it and just do it in your head. Look, it looks like a big X. 1 times 4 is 4. 1 times 9 is 9. Final answer. I know I don't have to simplify because I did all of the simplifying first. Here's the deal though. If I didn't simplify by the greatest common factor, like take a look at 32 and 8. I knew I could divide by 8, which is the greatest common factor between those two, 8 and 32. But if I would have divided by something smaller like a 2, let's say I would have done a 2 or maybe even a 4. If I would have divided these by a 4, I would have gotten a 2 and an 8. So my answer would have been 8 over 18 instead of 4/9. And if it's 8 over 18, I still have to simplify. So make sure when you're dividing that you are dividing by the greatest common factor. In fact, this is a great moment to pull out our journal and to add that information. So simplify first if you can by dividing with common factors. And we're going to write this over here to the side. The greatest common factor. You are going to thank me later, but that is a phrase that you're going to use in middle school and high school for a lot of math things. It's called the GCF, dividing by the greatest common factor. When you do that, you get the most simplified version of a fraction or of numbers that you need. So if you will divide by the greatest common factor or the GCF, then you'll do really well. In fact, this will be fun. I'm going to try to do this. G, C, F. When you look back in this journal when you are in middle school or high school, you can be like, oh man, that Miss Fisher, she really showed me how to do this. Okay, so let's go back to what we were working on. Just make sure you're dividing by the greatest number possible, otherwise known as the GCF. Okay? I would like to skip numbers 11 and 12 and move right along to number 13. It says, which fraction is not equivalent to the others? Guess how you're going to figure this out? You're going to have to simplify every single one of them to find out which ones of them break down to the same basic fraction. Okay? Is there one of these that you cannot simplify right now? That one, because it's a unit fraction. So 1/3. So let's just check 3/9. And if 3/9 simplifies to 1/3, then we know that's what we're looking for is 1/3. Okay? So let's just see. How could I simplify 3/9? I would divide each one by 3. And I would get 1/3. So far, this one and that one are the same. So we're looking for 1/3. So now let's go into this one and see. How do I simplify 8/24? If I divide each of them by, what's the greatest number possible I could divide them by? I could divide both of them by 8. And when I divide them by 8, it's 1/3. So that one's another one that is the same. I know I'm circling them lightly. It's because I'm going to use my red for the one that's not like the others. Is 10/30 1/3? It sure is. Look, you can just block off the zeros, and it shows you right there that it's 1/3. So that one's equivalent. Let's do 6/18. Can you divide each of those by 6? Yep. And you get 1/3. That one worked. How about 9/36? Divide each of them by 9 to get 1/3. What's 36 divided by 9? 4. If you said 3, you're incorrect. It is 4, so it's 1/4. That's the one, hopefully. Let's just put a little red dot by it and make sure the other one worked as well. 20 over 60. Well, you can divide by, what's the greatest common factor? I'll just tell you, it's 20. That's crazy, huh? 20 divided by 20 is 1. 60 divided by 20, you might not know that, but what's 6 divided by 2? It's 3. And then the zeros cross each other out, so it is 1/3. So that one worked. So the one that was not 1/3 was 9/36. Okay, so here we go. We're going to work now on the story problems. It says write an equation, then solve. Don't panic. We can do equations. Oh, I forgot. I wanted to show you, sorry, I do want to go up to these, numbers 1 and 2, and I want to actually solve those first. Because I want to remind you that even though we multiply a fraction by a whole number, you can still do this. Okay? Because what you do is you throw a 1 under the whole number, and you're going to extend the bar. But look, it's just a slope. That's all that changes. And you change that to an x. So you still have fractions. You're just extending the bar. So go ahead and do that on this one as well. It just looks like skiing on a slope. And you throw a 1 underneath it. Okay? Then we do all our normal stuff. So you just go like this. Do 2 and 3 have relationships? No. Do 2 and 1? Nope. What about 30 and 1? Nope. What about 30 and 3? Yes. Those ones can both be divided by 3. So that one would become 10, and that one becomes 1. So this looks like 2 times 10 over 1 times 1. What is 20 over 1, everybody? Any fraction over 1 is just the numerator, which just means 20 wholes. If I have 20 one-sized candy bars, how many candy bars do I have? 20. Okay? Let's do the next one. Why don't you pause the video and try to do this one and then check your answer when you come back. So you should have done this. 2 and 5 don't have a relationship. 2 and 1 don't. 35 and 1 don't. But 35 and 5 do. So you should have divided each one of those by 5 to get 7 and 1. So you have 2 times 7 is 14. 1 times 1 is 1. 14 over 1 just means 14. Okay? That's all it means. All right. Let's go to number 14. Let's use yellow. We just haven't used yellow very much. Actually, I don't want to use yellow. I want to use orange. It says, in the Fireside Ski Shop, 11/28 of the ski caps have tassels. Of the caps with tassels, 7/11 are blue. What fraction of the caps are blue with tassels? So look at all these clues that we're doing multiplication. 11/28, so 7/11 of that amount is what this looks like. So you're going to show your work right here. 7/11 of means times 11/28. Ready? Let's do our work. Extend the bar. Change it to an X. Look for relationships. 7/11? Yeah, I want a relationship with 7/11. I can go get a Slurpee. Just kidding. They don't have the same factors. So I move on. What about 7 and 28? They do. You can divide both of those by 7. So you'll get 1 up top and 4 on bottom. Okay? So I checked the 7. Now I move over and check the 11. Go down first. 11 and 28? Nope. Now go across. 11 and 11? Yeah. Anytime there's a number on top and a number on bottom, guess what they change to be? They just change to be 1, because what is 11 over 11? It's 1. Or 11 divided by 11 is 1, and 11 divided by 11 is 1. So I've got a 1 times 1 and a 1 times 4. So that's pretty easy. So what fraction of the caps in the shop are blue with tassels? There it is, ladies and gentlemen. 1/4. So 1/4 of the caps are blue with tassels. Will you take your blue and just circle the 1/4? All right, number 15. In the shop, 27/32, 27 over 32, of the jackets have zippers. Of the jackets with zippers, 8/9 have hoods. What fraction of the jackets have both zippers and hoods? So guess what it is? It's 8/9 of, which means times, of the 27:30 seconds. Here we go. Why don't you pause it and see if you can get it all on your own. If you need some help, you can stick with me though. Extend it. 8 and 9, nope, go across. 8 and 32, yes. They can both be divided by 8. So I'll get a 1 and a 4. Now I check 27 and 4, nope. 27 and 9, yep. They can both be divided by 9, which gives me a 3 and a 1. So my new numbers say 1 and 3 and 1 and 4. Hopefully you got 3/4. What fraction of the jackets in the shop have both zippers and hoods? 3/4 of the jackets have zippers and hoods. Let me use my blue. Okay, we're down to our last story problem on here. And it says, 5 of the 16 workers in the shop know how to ski. Interesting. They have written it with words and a number here to make you really think, what does that look like? 5 of the 16? It looks like a fraction, everybody. It's just 5/16. Don't be paranoid by that. Anyway, 5 of the 16 workers in the shop know how to ski. Well, that's good because they're working at a ski shop. So 1/5 of those who can ski know how to snowboard. What fraction of the workers can ski and snowboard? So you're doing 1/5 of those that can ski. So it's 1/5 of, and how many could ski? 5 out of 16. This one's going to be awesome. Extend the bar, place an X. If it's a unit fraction, you don't have to really check it because it already has a 1, so you just move to the next one. It's a 5. 5 and 16, nope. 5 and 5, what does Fisher tell you? They just make 1. So it's 1 times 1 and 16 times 1. The answer is 1/16. So what fraction of the workers can ski and snowboard? 1/16 of the workers can ski and snowboard. Can you ski or snowboard? I have a cool fact about Miss Fisher for you. I have never gone skiing. I've been snowboarding, but really I just got on it on my stomach and rode down the mountain. That was a long time ago, but I have never been skiing. Random fact about Miss Fisher for you. Okay, what I need you to do is, I'm going to try and get this done. Well, I'm not actually. I'll just catch you in the next video.